Anthralates. Anthralates is not much difference. Yeah? You have the carboxylic acid group there, that's similar to aspirin, and they have a minor group also to the carboxylic acid. That's anthracic acid. Okay, so it's based on this template. So this is acid, this is Boston. That usually you use, I think you have probably taken some Boston before. Yeah. So for period pain. Okay. So firstly, this carboxylic acid needs to be also to the minor group. Very important. Very, very important. Yeah. This is essential. If you change that to a carbon or oxygen, a bioisoster, remember last year? No? Okay. So if you change that to a bioisoster, it doesn't work. Okay. Activity drops. The 2,3' 3' di substitution is again very important. That makes it non-planar. If you take out these two substitution, you just have a benzene ring. Yeah, it'll be planar. Okay. If you add in the di substitution or even mono substitution, yeah, it'll be non-planar. And that helps in terms of the activity. Remember, again, the arachidonic acid, they want to have more pi-pi interaction as well. So they add in a second ring here. And if they found that if you actually make it non-planar, it's not the same plane, non-planar, then it helps you actually increase the activity of this as an anti-inflammatory. Yeah? If you put a monosubstitution, sample in here is this flufenamic acid, CF3, just one substitution, yeah, at the 5 position. Yeah. This is very potent, the most potent NSAID. Okay. Piroxicam doesn't have carboxylic acid. What does it have then? You have a thiol group, okay. What else does it have? It doesn't have carboxylic acid. So what substitute there for the acidity? Do you remember tetracycline? Yes. Yes. What looks familiar to you? I doubt it, lah. You guys are not looking at me. Do you remember tetracycline? Do you remember the top part of tetracycline? No. You can Google if you want to, the structure of tetracycline. Yeah. One of the prominent features of tetracycline, and also in here, as well as is the enol, or the enolate. Yeah? And enol is very acidic. In other words, it actually simply it gives up protons because of the 2 carboxylic acid. Yeah? 2 ketone there. Yeah? And that proton can be easily it's very acidic, simply dropped like that. Okay? So the potency of this piroxicam is 200 times more than aspirin. Why? Doesn't have carboxylic acid. Why is more potent? Because first, the formation of the enols is very stable. Second is that you have this heterocycle. So how have you learned about anthracycle in the first year? Why have you learned about anthracycle in the first year? What does it actually function as? Maybe I should ask it in the quiz. It functions as an electron sink. The electron sink actually will resonate, you will actually move around, distributed around, there's a resonance there. It can also go into this side of the molecule as well. In other words, this structure is very stable. Yeah, it can actually form, it can actually donate the acid very easily, and that structure is very stable when you have this heterocycle. If you remove the heterocycle, with example, you replace it with aromatic ring, the activity is terrible.